All right, what's good, yo? Link here. So for the daily question of yesterday, I actually started recording, but like I spent like almost like an hour trying to use like a kind of like a recursive EFS approach with caching, but it was still not passing the test. So I was getting like time limit exceeded. So I went and looked more deeply into Cadence algorithm to try to figure this out. So I'm gonna try after today's question. So let's finish the daily for today first, and then I'll post another video for the question yesterday. Okay, so let's see what we have today. Maximum difference between adjacent elements in a circular array. Okay, daily 34, 23. Okay, let's see what we have. Given a circular array nums, find the maximum absolute difference between adjacent elements. In the circular array, the first and last elements are adjacent. Okay, so in this case, will be 4 with 3. Oh, 4 with 1 and gives 3. Okay, this one should be -10 minus 5, right? Or like -5 minus, yeah. Okay, let's see. Uh, in this case, let's say we have, oops, this is too small. Let's see, let me increase this. There you go. Okay, so let's say we have 1, 2, and 4, but after 4, we should have 1, right? So what we can do is, what if we just add 1 here? Then we compare adjacent, so 1 with 2, 2 with 4, and 4 with 1, which is pretty much the same thing. And then, okay, yeah, I think that should work. Let's do circular array is equal to, actually what we can do here, where's the constraints? We'll have at least 2 elements. Okay, that's fine. So what we can do is do nums dot append uh, nums index 0, and then we have like best here is equal to, we kind of want the best, way. Is it the max? Yeah, the maximum absolute difference. Oh, it's the absolute difference. Okay. So in this case would be, let's say -5. Well, the absolute difference, let's say again. It's 4 minus 1, the absolute value of this. Okay. So this will always be positive. So we can do like -1, and therefore I in range of 1 to length of nums. Best is equal to best, oh, the maximum of best, and nums, and that's I. Actually, the absolute value, right? The thing's -5 minus -10. I was wondering if we can do uh -5 minus -10. Let's see. Can we just do the absolute value of 5 minus absolute value of 10 and then take the absolute value of those? Because like let's say we have uh 5 and -3, then if we just do uh 5 minus 3 and take the absolute value, we're gonna have 5 plus 3 plus 3. This gives 8, and then we return 8. But let's say we do negative. Oh, is it the same thing? I think it's the same thing. Let me do actually. Now if we do -3 minus 5, yeah, I think it's the same thing. Okay, okay. The order doesn't matter, I think. We're taking absolute value. Oops, it's 1, no. Okay, minus 1. We take math dot, yeah, 2. Oh, there you go. Absolute value of this thing. Okay, and then we turn max, oh, best, right? We append the first element to the end so we can get the circular feature. Best equals -1, because since we're going to do absolute value, it's always going to be greater than 0, but we can't have 0. Actually, that here this like 0, right? And then for I in range of the first element to the end, the best is going to be the current best, and then the absolute value of the element that we have minus the element before, and then we turn the best. It should work. See, okay, give it a quick submit. Okay, good. Um, okay, that's a quick one. I'm trying to go back to this question. This was like a really hard question for me yesterday. So I'm gonna try to use a different approach instead of doing this recursive thing. This is like n squared, and with Cadence algorithm, I saw that we can do in linear time. So I'm gonna try this right now and then post another video for this one. Okay, thank you guys. See you next time.